morning. What factors affect the coefficient of friction? That's what we're going to be studying today. So we're going to choose two surfaces. We're going to start off with our shoe and something simple like maybe the desk. And we want to calculate the coefficient of friction. So in order to do that, we need to measure the force of friction and the normal force. So if we draw our free body diagram of this situation, this is my great shoe. This is a spring scale. We're going to pull the shoe, drag the shoe along with the spring scale, apply a force to the shoe so that it moves with a constant velocity. That means our acceleration is 0 and we're in equilibrium. So whatever force the spring scale reads when we pull at a constant velocity is the frictional force. Technically the kinetic frictional force, because it's the friction that it feels when it's moving. We also need to find the normal force, so we'll find the weight of the shoe like we did in our FG equals mg, or F weight versus mass lab, to find the normal force. So I'm going to demonstrate this a little bit with some help. You'll come along with me. I have our great physics student here. So we're going to use our spring scales. Remember, there's two different types of spring scales. So if you have a nice light shoe like mine, you'll use this green spring scale, 0 to 5. You also want to 0 the spring scale. Let's zoom in real close on zeroing the spring scale. Or did you zoom in digitally? Okay, I can edit it. So pull it up until it's 0. Then you can just attach the hook of the spring scale to the shoe. And we're going to pull it along with a nice constant velocity, which is and our reading on the spring scale is about 1 Newton. Now, in order to get multiple trials, wonderful, bravo, we're going to add mass to the shoe. And remember, we need to find the normal force. The easiest way to find the normal force is to find the weight, and that's just to lift this guy up. Just lift it up like that. And then you can find the weight of the shoe measured by the spring scale, so it's about 3.2 newtons. Cool. So for our next trial, we're going to add mass to the shoe. We're going to do the same procedure. Go ahead and demonstrate one more time. Make sure it's 0'd again. And we want to pull with constant velocity. Notice it doesn't do that very much. So try your best to do that and get that reading when it's at constant velocity. You're going to do 4 different trials, so you can add more mass and add more mass. The last thing, go for it. Wonderful. So skipping to our last trial, I also want you guys to take a look at what's called the static frictional force. And static means it's stationary. And this force is bigger than the kinetic frictional force. So if we look down at our, can you see this well in the camera? When you pull it, so it's not moving yet. So just pull it a little bit, Ian. And then just as it starts to move, ooh, too much. Okay, so we need to switch spring scales. Oops. It's okay. So we're switching spring scales, making sure it's 0'd. We pull, and we should see it reaches some maximum force before we end up at constant velocity. So let's see if we can find that maximum force one more time. So that was about 8 newtons, and then if you pull it at constant velocity, yeah, still about 8 newtons. If you pull it at constant velocity, what is the kinetic force of friction? Okay, so that's around 5 newtons or 5.5. So that static force of friction, that force to get it to go from not moving to moving, is that last little thing I need you to put on your lap. Thanks. Good luck.